Hello, welcome to another video. This time I'm taking you through Statistics 2020 Excel question 2, and it's a linear regression and correlation question, and it's on a large data set as well. Now I think it's hard for me not to look at large data set questions and think, oh dear, this is large data set, this is going to really test me, but let's give it a go. Okay, so we've got a random sample of 15 days taken from the large data set for Perth in June and July 1987. Okay, the scatter diagram, figure 1 features, displays values of two variables for these 15 days. Describe the correlation. Well, it's negative correlation. That's pretty straightforward, and you can see that because it tends to be going down. And the variable on the x-axis is daily mean temperature. So this is daily mean temperature. Let's just put mean temp daily. And it wants us to, using our knowledge of the large data set, oh dear, suggest which variable is on the y-axis. Okay, hopefully you'll accept more than one answer here. As I've done with the others on these regression ones, I've got the answers over here so we can check them at the end. But I'm going to go for, I think as it gets hotter, it tends to rain less, yeah? Whereas when it gets cold, it tends to rain more. So I'm going to go for rainfall. And what the units, because I know they measure rainfall in the large data set, and the units I think are in millimeters. Yeah, we'll see what is acceptable there at the end. Now, Stav believes there's correlation between daily total sunshine and daily maximum relative humidity at Heathrow, and he calculates the PMCC and finds that when n is 30, R is minus 0.377. So clearly, as sunshine goes up, humidity goes down, whereas when humidity goes up, sunshine goes down. There we go. Carry out a suitable test to investigate whether this correlation is true. So just like all the other ones, we're going to have our hypotheses, H0. Remember, we need rho equals 0. The null hypothesis is always that there's no correlation. Now, he believes that there is a correlation between daily total sunshine and daily maximum relative humidity. Can you see that he's not suggesting that there's any direction in that? He's not saying there's positive correlation or negative correlation. That makes it a two-tailed test, which means we're going to have to halve that when we actually do our critical values, yeah? So I've got this from the last one I just did because I'm doing them all at the same time. Let's pull this table down. This is always what we need for a PMCC hypothesis test. Make sure you're aware of what it is and how it works. So this is how it works. We've got n is 30. And we know that R is minus 0.377. Now, n is 30 is down here. Now, remember, we've got to halve the significance level. So we're going to be using that value there, 2.5%. And so I'm going to compare. I tend to make the sign negative straight away, but you can do it the other way around in the mark scheme. I'm going to compare this to minus 0.377. Now, can you see that minus 0.377 is smaller than that? Yeah. Now, they did say, make our hypothesis clear. I hope those are clear, my hypotheses there. My critical value, I'm going to make it real clear. The critical value is minus 0.3610, yeah, after finding it in the table, yeah. There's two ways of doing these. You can either make this positive or you can make this negative. Yeah, they like using a negative because they know that the table's just full of positive values, and so it confuses people. Now, we've already dealt with the fact that it's two-tailed, and we've used the 2.5% value. Now, as you can see, this is more negative and closer to minus 1 than the critical value. Hence, once again, we're going to be accepting the alternative hypothesis. We're going to be accepting H1. Now, always have a comment in context at the end. Yeah, sufficient evidence to suggest there's a correlation. Don't say positive or negative because it was a two-tailed and we're just testing for correlation. That's the alternative hypothesis. So sufficient evidence to suggest there is a correlation between, now what were the two variables? Daily total sunshine and daily maximum relative humidity. Cool. Brilliant. Okay, right, there we go. Okay, on a random day at Heathrow, the daily maximum relative humidity was 97%. Yeah. Now, okay, that's interesting. So humidity's high. We've just demonstrated that there's a correlation between humidity and sunshine. And what's more, the correlation appeared to be, from our sample at least, a negative correlation. Yeah. So how many hours sunshine would I expect on this day where the humidity is very, very high? I'm just going to say, well, as the humidity is high, I would expect the sunshine to be low. Yeah. As the humidity is very high, and according to the sample, it's negative correlation. The correlation appears to be negative. My conclusion is going to be that we would expect less sunshine than normal on this day. Or should we say less sunshine than average on this day? Okay, right. Let's check our answers. What have they got? Really interesting to read the notes on these questions. Always read them because it's handy. Okay, negative was fine. Rainfall was good. Or you could have had pressure. Yeah. So apparently pressure, as daily mean temperature goes up, pressure goes down. But as pressure goes up, daily mean temperature goes down. That's interesting. Pressure, obviously, it's harder to get the units. It's in hectopascals or millibars. You can use either. Going on to the correlation, we've got the critical value is minus 0.361. Did we have that? Hope so. Yes, we did. Yeah, minus 0.361. And so, as you can see, significant result, and there's evidence of a correlation. They didn't say positive or negative between daily total sunshine and daily maximum relative humidity. That's good. Okay. Really interesting though to read the notes here. You know, do always look at it. They would have allowed for rainfall or pressure in that first one. No other quantitative variable for MB. Oh, the other quantitative variable for Perth is wind speed, but that scores 0 because wind speed isn't connected in that way. They would have given you a follow-through mark though if you got the units right on that. So there we go. Just knowing the units for wind speed would have got you 1 out of 2. You must have it in terms of row. Yeah. Look out for the one-tailed. That's wrong. So there we go. It's interesting reading some of these. It really is a correct conclusion based on in context, based on comparing with that. Yeah. Condone incorrect inequality. That's outrageous. Shouldn't condone that. Anyway, you can just say it supports Stav's belief as well, and that's a quicker way of doing it. Okay, for the last bit, what did I say? Humidity is high, and there's evidence of correlation, and R is less than 0, negative correlation, so expect sunshine to be low on average. So we're fine there, I think. Yeah. Check for the following 2 pictures. You can talk about fog because fog is humidity, if you see what I mean. Low sunshine, because I think a lot of people are going to specify the number of hours because of the way the question was put. They're going to allow for that. But like I say on these questions, when you've written your answers, write your answer first, then compare it to the notes. See how close you're getting. That's the best way to get better and better and better. Okay, I hope you enjoyed the video and found it useful. Keep up the hard work.